All right, let's get right into it. For years, there's been this high stakes game of cat and mouse playing out online. In one corner, you've got China's Great Firewall, and in the other, a new internet protocol that's supposed to be faster, safer, and pretty much impossible to snoop on. So, what happens when the unreadable gets read?
The Great Firewall, or GFW, isn't just some single piece of tech. It's this huge, complex system that's been evolving for decades. It has a whole bag of tricks to control what people see online, blocking websites, messing with DNS, even scanning for specific keywords. And then along comes Quick. This is the new-ish protocol that's a huge part of how the modern web works. We're talking over 30% of all web traffic. And its killer feature, total encryption. From the very first packet that leaves your computer, everything is scrambled. It was literally designed to stop this exact kind of snooping. Now, you can see how this would be a massive headache for any sensor, right? If every part of the connection is wrapped up in layers of encryption, how on earth can a firewall know what to block? It's like trying to read a letter that's been locked inside a steel vault. And yet, that's exactly what's been happening. Since about April of 2024, people started noticing that the Great Firewall was somehow able to single out and block specific quick connections. So the big question is, how is it picking the lock on this supposedly unbreakable code? Well, a team of researchers decided to dig in, and what they uncovered was a really clever, but also deeply flawed new censorship mechanism. Turns out the secret isn't some magic decryption superpower. It's actually an exploit. The GFW zeroes in on the very first packet of a quick connection. Now, while this packet is encrypted, the key used to lock it is derived from information that's sent out in the open. That means anyone watching, like a firewall, can figure out the key for themselves. So, this lets the firewall follow a pretty simple four-step dance. First, it snags that initial packet. Second, it calculates the encryption key. Third, it unlocks the packet and reads the destination. That's called the server name indication, or SNI. And finally, if that destination is on its blacklist, boom, connection terminated. But hold on, decrypting even one packet from every single connection crossing the border? That would be an absolutely massive amount of work. The computers would melt. So, to make it work, the GFW doesn't look at everything. It uses a shortcut, a simple rule of thumb to decide which packets are worth the effort. And this is where it gets really fascinating. That rule of thumb is dead simple. Only inspect a packet if its source port number is higher than its destination port number. And look at how effective that is. With that one simple rule, it gets to ignore over 70% of all the random UDP traffic out there, but it still manages to catch and inspect over 92% of the quick connections it cares about. That's just incredibly efficient. This perfectly captures the GFW's design philosophy, what the researchers call worse is better. The goal isn't to build a perfect, flawless system. The goal is to build something that's just good enough to get the job done at a massive scale. It's practical. But that focus on good enough instead of perfect also leaves some pretty serious cracks in the foundation. And as you can probably guess, it's those exact cracks that researchers figured out how to pry open. It's kind of ironic when you think about it. The very thing that makes this new censorship method so powerful, its ability to decrypt packets, is also its Achilles heel. Why? Because decryption takes processing power. The researchers discover that if you start throwing a whole bunch of quick traffic at the firewall, its ability to actually censor things just drops off a cliff. So you can see here, under low stress, it's super effective, catches almost everything. But as you ramp up the traffic load, the success rate just plummets. The system literally can't keep up. So this opens the door for something called a degradation attack. You can just flood the GFW with a stream of junk quick packets. Doesn't matter where they're going. While the firewall is busy trying to inspect all that junk, the real connection you want to make can just slip right through the chaos. But believe it or not, that isn't even the most dangerous flaw they found. Because the researchers found a second and far more serious vulnerability. One that actually allows an attacker to turn the Great Firewall into a weapon against its own people. I mean, listen to what they say in their paper. This attack can be used to block communication between any host in China and any host outside of it. This isn't about bypassing censorship anymore. This is about causing targeted internet outages.
And here's the truly scary part. It is ridiculously easy to do. An attacker, anywhere in the world, picks a target inside China.
They forge one single quick packet to make it look like it came from the victim. They put a forbidden website in that SNI field we talked about and send it to any random server outside the country. The GFW sees this packet, thinks the victim is up to no good, and immediately blocks the real victim for the next 3 minutes.
You can see how this just completely flips the system on its head. Instead of blocking a user for something they did, it lets a random attacker get an innocent person blocked from accessing a totally legitimate website. And the implications here are pretty severe. An attacker could use this to systematically cut off a company or a university, or even an entire region from essential services like DNS. You could cause serious, widespread internet problems inside the country. This threat was so real that the researchers did a responsible disclosure. They told China's own cybersecurity emergency response team about the flaw so that hopefully it could be fixed. But of course, the story doesn't end there. The global tech community is already fighting back, and this is just the next chapter in this ongoing technological arms race. Developers are already using the GFW's own flawed logic against it. Things like intentionally using a source port that's lower than the destination port to fly under the radar, or sending a dummy packet first to confuse the system. There's even a technique to split the forbidden website name across multiple packets, so the sensor can't read it. And of course, newer tech like Quick version 2 and encrypted client hello are also proving to be effective bypasses. And this isn't just theory. These solutions are actively being built into major web browsers and other tools that people use every single day. For every move the sensor makes, the open source world is already planning a countermove. It's a true chess match.
Which brings us right back to where we started. The internet is this constantly shifting battlefield. As our technology gets smarter and more secure, the tools of censorship have to get more sophisticated, which in turn often makes them more brittle and more vulnerable. So the only real question left is, what's the next move going to be?